A very warm welcome to WsCube Tech. So guys, in our previous session, we have covered that what is the major difference between arrays and lists. In our today's session, we will be talking about how to create these Numpy arrays. So we have been talking about arrays from a very long time. Now today, in our today's session, we will be talking about how we can create them. Plus, we will be understanding how to do slicing with the arrays, that how we can slice the arrays. And lastly, we'll be talking about attributes which are there inside our Numpy arrays. So let's get started. First of all, let's start with creating Numpy arrays over here. To create a Numpy array, all we need to do is first of all go to our command prompt. So here we'll go to command prompt. Once we are here on our command prompt, all we need to do is we need to write pip install, because Numpy does not comes inbuilt with our Python. We need to install a package over here. To install a package, we need to write pip install Numpy. For me, it's installed already. So when I run it, it will say requirement already satisfied. But for you, it will install it. Okay. Once the installation process is done, all you need to do is write import Numpy, and if you run it and if it is installed, that means it will not throw any error over here. If it was not installed properly, it would have thrown an error over here. So to use Numpy, we use the import key term. We use import Numpy as it's a package that needs to be installed, and to work on it, we need to import it in our Python. So import Numpy, and we can create an alias over here because we will be using this term Numpy often. So import Numpy as NP. Once we have imported Numpy as NP, all we need to do is next write ARR. I'll create a variable called as ARR. That means we are creating an array over here. To create an array, all we need to do is write NP dot array, and here we need to pass a list. So I'll be passing 1, 2, 3, 4, and then we need to print ARR. Let's run and see what output we'll get. So as soon as I run it, I'll get the output 1, 2, 3, 4. Now, how we can understand that it is an array? You can see over here that we have passed the values in a format of a list. That means comma separated values are there inside the square bracket. While at the same time, when we have received the output, there are no commas over here, which tells us this is an array. And even if you want to check its type, all you need to do is write print type of ARR. Now let's run and see. So if I run it, it gives me that belongs to the classes of numpy.endArray. EndArray means n-dimensional array. So we call it endArray over here, which is the short form for n-dimensional array. So I hope this is clear that how to create an array over here. There are several different ways, several different functions with which we can create an array, which we will be covering in our next session. But as of now, a simple array can be created like this, that you need to write np, that is the alias for numpy, dot array. And here you need to pass numbers in a format of a list. So if I would have written, because as I have said that array has only single data type, if I would have written 5.6 over here, let's run and see what output we'll get. So it would give me all the values as floats. You can see it's 1 point, 2 point, 3 point, 4 point and 5.6. Similarly, if I would have given here 1, in that case what would have happened, all of them would have become a string. That right now 1 is what? String, 2 is a string, 3 is a string, 4 is a string, and 1 itself is a string. So this is how array works over here. Once we are done with the creation of arrays, you can create multi-dimensional arrays over here as well. Like you can pass another list. Let's say I'll be writing 5, 6, 7, 8 over here, and I'll pass another list. So in a square bracket, which will now create a matrix formation over here, which is 2-dimensional, that we have 2 rows and 4 columns over here. Similarly, we can create another one. So I can put a comma and create another row over here. For example, I'll be writing 1, 3, 5, 7. And if I run it, I'll get the output with 3 rows and 4 columns. This is how an array can be created. Now let's move ahead and talk about slicing of arrays. How we can slice an array. To slice an array, we have a very simple method. Let's first talk about only one row. Let's suppose if we have only one row over here. Let me just run it and show it to you. So right now we only have one row. Okay, we have printed this array. What I'll do, I'll just put this inside a comment here. So we have printed this array, and if I run it, we will just receive the array over here. Now what do I want? I want only first and second element from here. To obtain first and second element, all we need to do is write print. Or we can make the changes over here only, that print and ARR we have written just like how we do slicing normally in our strings or lists. Same way we have to do it over here, that we know our first element is on index number 0, the second one is on 1, then 2, then 3. So if I want first and second element, then in that case what we need to do, we need to write the starting value, colon. Our ending value is 0, 1 and 2. Because I want only 1 and 2, we will be writing plus 1 value. That means 1, 2 is there. So 0, 1 and I'll be writing 2 over here. So as soon as I run it, I will only receive first 2 elements. Okay, so that means it will go from 0 index to up to 2 and the last element will not be counted. So if I would have gone up to, so okay, let me just write it as 10, 20, 30 and 40, so that now it will be much more simpler to understand. So right now I will only get 10 and 20 over here because the third element, that means the number which is on number 2 index, that is 30, but we don't receive 30 because we always write the last element as +1. Okay. Similarly, if you want the default value, if you don't want to write a default value, you can just leave it like this and you will still get the same thing over here. Same goes for the ending value as well. Suppose we have written the starting value as 2. That means it starts from 0, 1, 2. That means 30 and 40. We want to obtain 30 and 40. In that case, you can just write 2 and it goes up to the end. For that, you can just leave it like that. And if we run it, we'll get the output 30 and 40 over here. Similarly, you want to obtain all of it with the space of 2. So in that case, what you can do, you can give a colon over here. That means you can define the starting value. That starting value, that means if you're not writing anything, then the starting value will start from 20. If you're not writing anything for the ending value, that means it will end at 40. And if you want to give a gap in between, so we can give a gap of 2 in between. So it will now give us 10 and 30. That means it will print the first element. And after a gap of 2, we have our third element, that is 30. Similarly, if you want to obtain the reverse, you can write -1 over here, and if I run it, we will obtain the reverse of it, that is 40, 30, 20 and 10. So this is how slicing for one-dimensional array works. What if we have a two-dimensional array? Let's have a look on how it can be done. So if we have a two-dimensional array over here, and I'll just put a comma and add another list of 50, 60, 70, 80. And now what do I want? I want the first and second element of the first list and the second and third element, and the first and second element of our second list. In that case, what I'll do, I'll write, so from here first and second element is 0 to 2. So 0, 2. I'll put a comma and write again 0, 2. Now let's run and see what output we'll get. So as soon as I run it, I'll obtain a matrix over here of the first two elements of both of our lists, that is 10, 20, 50 and 60. So these are the first two elements of both of our list. Similarly, if you want to obtain the middle two numbers, in that case, you can just write that the starting value is 1 and the ending value is 0, 1, 2, 3. So ending value is 3 here. And the same, if you want the first two elements, then you can do the same as well. Similarly, if you want to obtain 20, 30, in this case, you can write 1 over here and it goes up to 3. That's why we'll be writing, so 0, 1, 2, 3 and again 1 and 3 here. So now if I run it, I'll be getting 60 and 70. So similarly, if you want to obtain it from one of them only, suppose if you want to obtain from one of these lists, okay, in that case, what you can do, so these lists have been indexed as this one is on 0 number, this one is on number 1, okay. So from 0 index, that means from our 0th list, so the list that is on our 0 index, that is this one, 10, 20, 30, 40, what I want to obtain, I'll put a comma, I want to obtain, let's say 10 and 20 only from here. Okay, in that case, what I'll do, I'll just write 0, 2. So now if I run it, I'll get output 10 and 20. Similarly, if I want to obtain the first two elements of the second list, in that case, I'll write 1 over here because the index number for this list, this whole list is 1. So we'll run it and we'll get 50 and 60. That means we are going inside the list and we have two lists over here. So we are going inside this list. Previously, we were going inside both of them. Now we are going inside the first list and we are treating this one as on number 0 and this one as on number 1. So from number 1, we want two elements, that is 50 and 60. Similarly, if I write comma and write over here 10, 30, 50, 70. Okay, and I want to obtain any element. Let's say I want to obtain 50 and 70 from here. For that, the index value of this list over here would be 2. Okay, because this one is on number 0, this one is on number 1. And this one is on number 2 over here. Okay. So number 2, from number 2, we need to obtain 50 and 60. For 50 and 60, what I'll do, 50 starts from index number 0, 1, 2. So I'll be writing 2 and I'll put a colon. That means it will go up to the end. So if I run it, I'll get the output 50 and 70 over here. Similarly, if I would have created a list, an extra list over here with a not so similar dimension. Suppose I have this one as 4, this one as 3 and this one as 4. It would have been throwing me an error. Why? Because the size over here is not same. So if we are creating a multi-dimensional array over here, in that case, we need to check, we need to keep in mind that we need to put a size as same for all of them. So that if there are 3 rows, so if there are 4 columns in first row, then there should be 4 in the second one and there should be 4 in our third one. Okay, so this is how the slicing work over here in our arrays. Now let's move ahead and talk about the different attributes that we have in our NumPy array. So first of all, let's start with the shape. So I'll just put this one inside the comment. So if I want to find the shape of an array, in that case all I need to do is write np.array. No, we don't have to write np.array, we need to write np.shape. We need to find a shape. Whose shape we want to find? Array's shape we need to find. So as soon as I run it, I'll get the output 3, 4. Now what is 3 and 4 over here? 3 over here is the number of rows. So there are 3 rows and 4 columns. So I'll just print it as well. So let's just print ARR. And now if I run it, I'll get the output like this, that we can clearly see there are 3 rows and 4 columns. Similarly, if you want to find the size, that means how many total elements are there. Right now we can see that there are 3 rows and 4 columns, and if there were multiple of rows and multiple of columns and we want to count how many total elements are there, in that case what we will be doing, we'll be using the size attribute. So we'll be writing np.size, and in the size we'll pass ARR. That means we need to find the size of ARR, and as soon as I run it, I'll get the output 12 over here, that in total there are 12 elements, 4 in this one plus 4 in this one plus 4 in this one. So 4 times 3 is 12. Similarly, if you want to know the dimension, we can clearly see it is in 2D, but if we have endless dimensions in that case and n dimensions in that case, we need to find the size. In that case, we need to find the dimensions, that how many total dimensions are there. For that, we will be writing print np.ndim, n dimensions of array. And if you run it, you'll get the output as 2, because there are 2 dimensions. First dimension is this one where we have 3 elements, and the second dimension over here is this one. Lastly, if you want to find the data type, if you want to know what is the data type of this array over here, you can just write print arr dot dtype. Dtype will give us the data type of this array, and as soon as we run it, it will get int32 as its data type. So I hope guys that it is clear how we can create arrays over here, how we can do the slicing in the arrays in the 1 dimension, 2 dimension, and how we can use different attributes which are there in our NumPy arrays. In our next session, we will be learning how to create NumPy arrays using different functions. So for now, we have just created it with using np.array. In our next session, we will be talking about the different functions with which we can create the NumPy arrays. So stay connected guys, and I'll see you in the next session. Thank you.